Welcome to literally every test. This is probably like the most important class of our fundamentals. I know I've been saying that about every class, but this is a very, very important one. Today we're going to be learning about the basics of statistical testing and why is it important to know, how a test works. I'm going to teach you exactly how every single test works. So that's why this class is so important. I'm really happy I managed to put everything into slides. Everything you learned here is going to be applicable to every single test you do, in your life, probably. Probably not all of them, but the vast, 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 vast majority. And in a starter course, for sure, every single one. First thing I want to let you know is that there's a huge disclaimer here. I'm going to be using the term mean number to mean test statistic, okay? And it's just because I'm simplifying that. So whenever you read that in a book, this is the official term. Test statistic, but I'm going to be calling that the main number because it's just simpler to pronounce. Okay, well, we know that in science we're skeptical, right? So let's say you have this hypothesis. You're saying, oh, social media causes depression, right? Well, this could be represented by this conceptual model. We're going to have one variable here called social media, okay, predicting another variable called depression, right? So social media use is going to have two conditions. So it's the experiment in which we have two conditions. We're going to have a condition with Instagram, a condition with no Instagram. The condition with Instagram is called treatment because it's the one that we're trying to, make people depressed with. And the no Instagram is the control, right? You learned about control, right? It's the thing where you don't do anything just for comparison. Cool. We randomly assign participants to use Instagram or not, right? And then with depression, we're going to measure depression by asking people the question, hey, do you feel depressed? From strongly disagree, 1, 2, strongly agree, 7, right? They read the statement, they answer that, and people are going to be answer that. Cool. This is how we're going to run this experiment, right? The question is, what's the difference in depression between using Instagram and using no Instagram, right? Like if you see models every day and you're a woman, right, are you going to be feeling more depressed than if you don't see, or if you're a guy, if you see all these successful crypto bros, do you suffer? I hope not. I hope you're all happy. But the question is, what's the difference between those two? So show me evidence that there is a difference, because maybe there's no difference. Maybe the difference is 0. Maybe everyone's depressed, right? So show me evidence that there is a difference, and show me evidence that this difference is not 0. Okay. And only then can you say that social media causes depression, once we see that the difference is not 0, right? So it's this science skepticism of checking if things are 0. So let's run our test. We'll start with a simplified null hypothesis, which is actually pretty accurate in day-to-day experiments. People conduct experiments. We're going to be checking out if, hey, is the level of depression among people who use Instagram the same as the level of depression among people who use no Instagram? And that's the null hypothesis. If they're the same, it means that there's no difference, right? So this is the most important thing. If the difference is 0, it means that there is no difference, right? That's why our null hypothesis is phrased this way. So social media causes depression, right? So let's say we ran this test. We found out that the average amongst everybody, right? Some people say 4, some people say 5, but the average is 6. Some people say 4, 7, 6, whatever, 7, 7, 7, 5, 5, 5, 5, 5. The average is 6. Okay, so the average in depression among people who used Instagram throughout this month, let's say we put them to use Instagram for a month, is 6. Okay, let's put that aside. Now let's look at the other group, no Instagram, people who spent the whole month without Instagram, right? Their depression is 5, right? So the average depression there is 5, right? This is the average amongst everybody in the data set. Cool, nice. So now we have average 6, average 5, and these are the two averages. Now, literally every test has a main number, okay? Let's learn what's the main number. What is this main number? So here, the main number that we're trying to look at is that number we talked about in the null hypothesis, the difference being 0, right? So 6 minus 5 is 1. This is the mean difference, right? So in this case, in this situation, it's called mean difference. In every test, it's going to have a different name. So sometimes it's going to be called coefficients, many different things. We're going to talk about that later. For today, we're going to use this example of mean difference, okay? So the main number here is the mean difference. And the mean difference is 1 because it's 6 minus 5, right? Now, you're saying social media causes depression. Okay, cool. Let's make that claim. And it definitely seems like it, right? So the average for Instagram users is in depression is higher than people who didn't use Instagram. So that definitely seems to be what's happening. So let's look at the official null hypothesis in a second. In the population, the mean difference in depression between Instagram and no Instagram is equal to 0. Okay, this is the null hypothesis that we were working on, and this is the null hypothesis that we're testing. We're thinking to ourselves, is this actually what's happening here? Cool. So we had that question, right? What's the difference in depression between Instagram and no Instagram? And then we got the answer. It's 1, right? It's easy, super easy, right? So literally every test has a main number that we check if it's 0 or not, right? Okay, so let's look at what that means, right? It's either yes or no. So this is how it works. It's either yes or no. Is the main number equal to 0? If it is equal to 0, we retain the null hypothesis. We're going to look at the null hypothesis and we'll say, hey, in the population, the mean difference in depression between Instagram and no Instagram is 0. Actually, we found that the mean difference is 0. Okay. If it's not, we're going to reject the null hypothesis. If the mean number is not 0, we reject the null hypothesis, right? We're going to look at it and say, no, that's bullshit. That's bullshit. It's not 0. Now, the question is, let's go. Preschool. Is the main number equal to 0? No, right? It's clearly 1. So let's reject the null hypothesis, right? No, not today. That would have been too easy, okay? And this is the reason why statistics is a little tricky, but we're going to understand why the answer is no. Not yet, okay? We're going to talk about that later. Maybe it might be, but for now, we can't conclude anything. Look, we have this very important bit of the null hypothesis that says in the population, right? So in the population, is the main number equal to 0 in the population? That's the question. That's the real question we're asking. And that's why inferential statistics exists, right? The number 1 is the number that we found in the sample, because these were the averages that we found in the sample, right? 6 minus 5. It's literally the opinion of 300 dudes. And who gives a fuck about the opinion of 300 dudes? I don't give a fuck. No one gives a fuck. It's just 300 dudes. We want to talk about the overall population. We want to talk about the entire world, like the 1-2 billion users of Instagram. That's what we're interested in. So how could we possibly think of generalizing 300 dudes to like 2 billion social media users? By the way, this generalization from 300 people to 2 billion people is the process that we call inference, right? It's an inference. So this is why we call this inferential statistics, because we're making an inference about the population based on the sample. We have to make an inference about the main number in the population.